All right, today we're going to be looking at expressions, formulas, and solving equations. And we want you in this lesson to be able to simplify and evaluate an expression and solve a linear equation. Algebraic expressions, they consist of one or more numbers and variables along with one or more arithmetic operations. Some examples of this would be like 5x plus 2 would be an expression. You might get expressions with parentheses, such as the quantity x plus 3 squared. Both of those would be an example of an expression. Equations, on the other hand, are a sentence stating that two mathematical expressions that we just talked about are equal. So now if you take like the 5x plus 2 we just had and set it equal to something else, now that becomes an equation. Same with this second one. If we now put that equal to a number, that becomes an equation. Okay. When solving, we want to follow a mathematical order to make sure that we come out with the correct solution. So we would do what's called order of operations, and there's an acronym called PEMDAS that can help us with this. Acronyms mean each letter stands for something. So in PEMDAS, the P stands for parentheses, and the E stands for exponents. We want to do any exponents after evaluating stuff inside the parentheses. Next are the M and D, and those are at the same time because multiplying and division are really doing the same thing. They come next, so multiply and divide. And then finally, adding and subtracting come last. And again, those are done at the same time because adding and subtracting are really doing the same thing. So we want to do these operations in that order. And when you get to this multiply and divide and add, subtract, we always work left to right. So you want to make sure you start on the left like you do when you're reading and work to your right. All right, so here's some examples down below. These are on your note sheet too. We want to evaluate and see what we get for each of these. So first one here, we see we do have parentheses, so we want to look to evaluate those first. This first one here, nothing to evaluate, so then let's go to the next one. Here there is an operation in there, so we would combine the 4 and the 3 to get 7. Okay, so now that all our parentheses are evaluated, we check to see if there's any exponents. We don't have any exponents here. So then we work multiplying and dividing. We do have some multiplying here. So multiplying 2 and 5, we get 10. Multiplying 3 and 7, we get 21. Finally, do the last operation of adding, and the answer to this one would be 31. B, okay, here we got multiple sets of parentheses. You can see these brackets, they work just like parentheses, and we also got another set here. Whenever you have multiple, you always work inside out. So we want to start with this inner parentheses and do that one first. So we would want to start with the 30 divided by 6. That's going to give us 5. Okay. Now we want to continue evaluating this bracket. 5 plus 5 gives us 10. And then finally, now we're multiplying to that outside number, and we get 20. Okay, so make sure when you got more than one set of grouping symbols, work inside out. A couple more of these. C. Now, this is again an expression over here. But we don't have all the numbers, so you can see there's now some variables. So that in that case, what we want to do is some substitution to start. So here they're telling us x is 3. We want to substitute that number in there. They're also telling us y is 4. We want to substitute that number in there. So first thing you want to do on these types of problems is substitute. So let's plug those numbers in. So now we got 3 and 4 plus 8. Now it's just like before of going through and working PEMDAS and getting the answer. So plugging those in, we're working the parentheses. We got 4 plus 8 is 12. We want to start with those parentheses. Okay, now what we got left here is multiplication and division. Okay, we talked about before we want to work that left to right. So first one we'd want to do is 3 times 12, giving us 36. Then divide by the 12 because that's to the right, and the final answer here looks like it's 3. Okay, let's start one more of those. Okay, on D, again, we want to substitute. So first step, put all those numbers in. So we're putting in 12 in for the X. We're putting 8 in for the Y, minus -3 in for the Z. And here we got the same variable on the bottom, so we're also putting the same number in there. Okay, so now looking at this, we do have some parentheses. They're all evaluated. Okay, so then we look for the next thing. Do we have exponents? Yes, we do have an exponent on this one, so we want to do that first. Okay, exponents, recall, and we'll talk more about these as we go throughout the year, mean you want to do that twice. So if we got -3 squared, -3 squared means we want to multiply -3 times -3, and that's going to give us a +9. And so that bottom of that's going to evaluate to +9. Be careful when doing that on the calculator. If you type in on your calculator -3 and square it, your calculator can give you the wrong answer. Here it's -9 and not +9 because your calculator doesn't know to put that negative with the 3 unless you put it in parentheses. If you put it in parentheses, now your calculator knows that negative is supposed to go with the 3. And now if you square it, it gives you what you should have, 9. So make sure you put those grouping symbols in the calculator if you're using calculator. All right, now to evaluate the top, we got multiplication and some subtraction. We want to do the multiplication first. So 2 times 12 times 8 would give us 192. Minus that -3. Okay, minus a -3. We know minus a negative is the same as adding. Some of you might like the trick of doing the double slashing. That's fine to do. You can do that. So that is going to come out to be 195. And we do want to simplify the whole top and whole bottom, the numerator and the denominator, before getting to the final answer here. So that is going to come out to be, let's see, looks like we get answer of about 21.6. All right, simplify each expression, write the answer in standard form. So if you have expressions that have variables, but we don't have any substitution, then you want to go through, simplify out till you get all the expressions simplified, and then what this standard form means is combine any like terms being same variable with the same exponent, and you usually write it from highest to lowest power, or that's also sometimes called degree, which we'll talk about in later lessons. Okay, so you, looking at this one, have some parentheses. Nothing in these parentheses, though, is like terms, so we can't combine anything there. So then we go to the next thing, which is multiplying. We do have some multiplying. So here, we want to distribute this 3, multiply that 3 to each thing. And so what we're going to end up with is -10x. That does not get distributed because there's a plus sign in between. The 3 does get distributed, so if we multiply each of these by 3, we'll end up with these terms. And then the plus 4x squared does not get that 3 distributed to, because again, we have another plus sign separating it from the parentheses. So now go through and find any like-powered variables that we can combine together. These two I'm going to start with because that's the highest power term we have. So if we add those two like terms up, we get 16x squared. Okay, now move to the next highest one. Looks like we got two x terms here, so adding those up, negative 10 plus 6 is negative 4x, and we can just write that as minus 4x. And then finally we got this minus 6 that does not have any like terms to it, so we just add that or subtract that term off the end. So that would be the final solution there. Let's look at one more of these. This next one is a problem or one similar to it that oftentimes you'll see on the ACT test. And the reason is it's not hard, but there is one part to it that a lot of students have trouble with. You can see here we definitely should distribute, and we should definitely distribute here. It's this second distributing that a lot of students get wrong. You have to include that negative sign when distributing through, because it's really, when you subtract, it's like adding a negative 4. So negative 4 is what we need to distribute there. So distributing, we get 4x minus 2. Here we're distributing a negative 4, so negative 4 times 3 is negative 12x, and then negative 4 times 1 is negative 4. And it's this negative sign that not everyone gets, and sometimes gets this problem wrong. Okay, we want to make sure you guys know how to do that. So now do the last step of combining like terms, and we get negative 8x. Negative 2 minus 4 is minus 6. So that would be the simplified expression there. All right, some word problems. When going through word problems, try to pick out the important information. If there's any formulas, make sure you see those, and then try to solve it out as best you can. So this one says the pyramid arena in Memphis is the third largest pyramid in the world. The area of its base is 360,000 square feet, and it is 321 feet high. It might be a good idea as you're going through to underline or circle the information you probably think is going to factor into the problem. The formula for the volume of a pyramid is volume equals 1/3 area of the base times height. Okay, so find the volume. There's our volume equation. So just like those problems we did at the beginning here, we want to substitute in what's the area of the base and what is the height. Well, they told us the area of the base was 360,000, and the height was 321. So now on our calculator, we just want to type that in, and we should be able to get the solution here. When typing in fractions, you can just do that by putting it as, or with division sign. So 1/3 can be written like that, times 360,000, and then times again 321. And looks like we come up with an answer of 38,520,000. And on these problems, word problems, you should be writing down units just to make sure that we did put in correct units here. Everything was in feet, so this would be in cubic feet. All right, one more here. The perimeter of a triangle is shown to be this, where A is 9 and B is 10. So again, similar to problems we did earlier, now this is just with a word problem. Substitute that information in. So we know A is 9, so anywhere there's an A, we want to substitute that amount in for. And then we know B is 10, so wherever we have a B, substitute that in for. Let's figure out what all these sides are equal to then. So for putting this in here, we got 2 times 9, which is going to end up being 18 for that side. Here we got 5 times 9 plus 1. So we know that's 45 plus 1, or 46 for that side. Here we got 0.5 times 10 squared. Now here's where we got to apply some PEMDAS here, some order of operations. What do we do first? Do we multiply the 0.5 and the 10, which it looks really tempting to do, or do we do exponent? Well, we know from PEMDAS after parentheses we should do exponents. So before we can multiply the 0.5 and the 10, we do need to do this exponent. So 10 squared, or 10 times 10, is going to be 100. Now we want to multiply that to the 0.5. So half or 0.5 of 100 would be 50. So that's how long that side is. So now look at what the question's asking. They want us to find perimeter. That's a term you should know from last year in geometry. Perimeter means to add up all the sides. So if we add up 18, 50, and 46, we do get the perimeter of this, which comes out to be 114 centimeters. All right, some other terms you should know when working order of operations or these word problems are some of the key words to indicate the operations. Operations are the main things that you're doing within the expression or equation. So words like add to, increase by, more than, sum, addition to are all talking about adding or putting the number together. So an example would be like 5 increased by a number. So then as a mathematical sentence, 5 increased by, that's our key here for adding a number. If we don't know what that number is, then you can put a variable like n or x in for that. And the next one, subtracted, decreased by, less than, difference, taken away from, are all keys to indicate subtraction. So if you had something like 4 less than a number and you want to write that in a mathematical sentence, you would use subtraction to do it. Now this one is a little bit tricky. A lot of people right away would do 4 minus n. That is actually incorrect here. Because if you are subtracting 4 less than a number, the number is actually what comes first here. And then we're taking away 4 from that. So that should be written as n minus 4. And with subtraction, it makes a difference. Adding, we could have switched these two around in the last problem and also written as n plus 5, because adding doesn't matter when what order you add things in. Subtraction, it does. If we take something and subtract it, it makes a difference which comes first. So you got to make sure you look at, if it's saying 4 less than a number, that means 4 should be taken away from the bigger thing. Okay, multiplied, product, times, 1/3, 1/2, 1/4 of, twice, all are indicating multiplication, okay, timesing. So this one to the right here, this example, 5 times, okay, the sum, okay, if we're summing, that means two things are being added here. So that's indicating we're going to have a parentheses here to make sure those get added up before they get multiplied. 9 plus some number. So that would be written as 5 times the quantity, 9 plus n. The next one here, quotient divided by. Those are all division. And so example, twice the sum. Okay, twice is indicating 2 times the sum. Okay, so again, we need some parentheses here. A number, so we don't know what that is, n. And, so here's our plus symbol, because now we're switching over in our sum, 8 divided by 3. And so a number and 8 divided by 3. And the last one is the same as or equal to. That's our indication of an equal sign. Okay, is the big one. Anytime you see is, almost always in a math sense, that's going to mean equivalent or equal to. So this one says the length of a rectangle is twice the width. So as an equation then, length we could use like L is equal to twice the width. All right, let's try a few of these out here. So now these are some solving of equations. Your goal is to try to get the unknown thing alone. Okay, our unknown thing is our x here. So we want to do the opposite to move these things across. Okay, so the two things here are this 2 and this 6. We want to move the 6 first by doing the opposite. Opposite of adding is to subtract. So we want to minus 6 from both sides. The goal is to make that equal 0. And 6 and minus 6 does equal 0. So now we got x over 2 equal to what's left over here, which would be 8. Okay, so now we got dividing. Opposite of dividing is to multiply. So now we want to times both sides by 2. Okay, whatever you do to one side, you always want to do to the other. And now we're left with just our unknown quantity equaling 16. And so the missing thing in that problem was 16. All right, in B, okay, here we got a bunch of these terms over on the left side equal to 16. The biggest thing you should be able to do on these types of problems is see that all these terms are actually the same like term, and we want to combine those together. So anytime you got like terms, start by combining together. So now you just go through 7 minus 3 would be 4, 4 plus 2 is 6, 6 minus 1 would be 5a. So we can combine all those a's together to equal 5. Now this becomes a one-step equation that's pretty easy to do. Divide both sides by 5 to get our solution. And so we find out here that a is equivalent to 3.2. And you could get that on your calculator just by doing dividing 16 divided by 5. You could also write this as a fraction, because sometimes on like ACT or some of those tests, they'd be fractions, so then you just write it as 16/5. So either of these two would be acceptable answers. All right, the last one here, C. Okay, now we want to solve kind of a multi-step one here. Go through, do any operations first, try to get everything simplified, and then do it. Now you can see the left side, not really any simplifying to do. On this right side, though, we got some different steps we got to take. One is to multiply, okay, because those inside the parentheses, we can't combine those terms. So if we multiply that out, distribute, we would end up with negative 9y. Negative 9 times 5 is negative 45, plus 6 times y is 6y, plus 6 times 8 is 48. Now, like we did on that last problem, combine the like terms. These are like terms. These are like terms. So let's put those together. So combining our like terms, that'd be negative 3y. Negative 45 and 48 would be 3. Now we're starting to get somewhere where this is a little bit easier. Do the opposite now. Let's subtract the 3 to get all our number terms or constant terms to the other side. So that would be now 24 over here. Final step, we can divide by negative 3. And we get the answer that y is equivalent to negative 8. All right, Carl wants to replace the 5 windows in the bedroom of his 2-story house. His neighbor has agreed to help him install them for $250. Again, looking for that important information as you go through. Carl has budgeted $1,000 for the total cost of replacing the windows. What's the maximum amount he can spend on each window? Okay, a lot of times this question right here is one of the most important things, because that's telling you what they want you to find. What is the maximum amount you can spend on each window? Okay, so we know, and it looks like we missed something here, that he does need to replace 5 windows. Now there is this word 2 here. You got to be careful. That's not really important information. That's just a descriptive word of the house. So he has 5 windows that he wants to install. Now you want to figure out what's the total. It looks like Carl has 1,000 here. So whatever he spends can't go over $1,000 because that's his budget. What does he have to pay? Well, he has to pay for installation, which his friend looks like is going to help him for $250. So that cost is going to get paid out no matter what. The other things then that he needs to spend money on are those windows. And since we know there's 5 of them, we want to do 5 times the number of windows plus the $250 he has to pay his friend has to equal 1,000. Well, if we just minus that cost, we know we have to pay the friend of $250. That's leaving Carl with $750 to buy windows. If we divide that equally among the windows now, we can find out what he can spend on each window. So if you take 750 divided by 5, it looks like Carl can spend $150 per window. So that's an example of some solving here of an equation. All right, try the practice on your own.